Describing the state of the atmosphere, as I mentioned, you just grab onto temperature and moisture especially, and then precipitation amounts. We have observation platforms all across the country that are taking snapshots of the weather at least once an hour, most of them, and sometimes more frequently. But describing the state of the atmosphere is basically temperature, dew point to get our humidity, and then precipitation amounts. Pressure is also part of that as well. So we take that snapshot of the atmosphere, and we'll find when the maximum temperature occurs, and usually it's early to mid-afternoon. The sun heats the ground, and eventually as the sun starts passing past noon hour, you get less and less heat from the sun the later in the day you go. So the maximum temperature delays your peak heating. Peak heating starts at noon, and then it starts diminishing, and then our high temperature will eventually delay that 3 to 4 hours usually. High temperature is usually 3 to 4 in the afternoon. Minimum temperature delays sunset by almost 12 hours sometimes. Just before sunrise, the earth is cooling all night long, and then your minimum temperature occurs right before the sun starts to rise. Dew point, when you cool the temperature of the air down to this particular temperature, which we call the dew point, you'll have the air become saturated, and then dew or water vapor will condense. So we monitor that dew point to see how much moisture is actually in the air. And then when you compare the temperature to the dew point, you get what we call relative humidity. And it changes throughout the day. It's usually the driest during the afternoon when your maximum temperature is occurring, and dry air lowers your dew point. And then your humidity is usually near 100% when dew is forming late at night or early in the morning. Precipitation amounts are always monitored. In terms of snow, we try and analyze that as a ratio, how much water is in the snow, and 10 inches of snow is generally correlated down to about 1 inch of water equivalent precipitation. Air pressure is also monitored closely because that'll tell us where we are in relation to the next high and low pressure system. What is our pressure tendency? And we'll see if it's pressure rising, high pressure is probably approaching, or if pressure is falling, a low pressure system may be nearby, or a front, cold front or warm front may be nearby. So anytime the pressure is falling, you might expect you're going to get some precipitation in the near future because you're probably going to be dealing with a front or a low pressure system. We monitor wind direction and speed closely as well because that'll tell us where we are in relation to the high and low pressure. And that's something you'll be answering in some of your questions in the assignments as well. As high or low pressure are approaching you, what is the change in wind direction over a period of time as the high is approaching, and then it's over you, and then it passes beyond. So we describe the wind direction from the direction it blows from. So if we say there's a west wind, the wind is coming from the west, moving toward the east. So anytime we say a wind direction, that's the direction the wind is blowing from. Just remember that. That'll be important. Sky cover is also measured in fraction of the sky, in tenths, and we monitor that in the observation systems. But that's basically how we do the sky cover. Weather watch is done by National Weather Service, especially because they're the ones that issue the hazardous weather alerts. So the weather watch is mostly done by them for the United States, and the warning system is driven by the Weather Service as well. If imminent severe weather is about to develop or it's already happening, those weather warnings will come from the National Weather Service. Weather satellites are a huge part of monitoring the weather now. Those satellites in the sky will give us instantaneous snapshots of the cloud formations as well as moisture around the planet. One particular type that we have is called a geostationary satellite. It stays over the exact same place on the Earth because it's spinning at the same rate as the Earth, about 22,000 miles above the equator. And then it's generally following the Earth. We place those satellites in an orbital path that allow us to get constant views of whatever portion of the Earth that they can see, and they send those images back to Earth, and we monitor exactly how weather systems are evolving. There are 2 satellites that provide a view of North America, and we usually place those 2 satellites, one over the East Coast and one over the West Coast. So we can get a snapshot of the United States from 2 different satellites. There's a little bit of overlap in the middle of the country, and we utilize that to really get a great view of how weather is evolving across the United States. There are also polar orbiting satellites that we use. They're much closer to the ground. They're only about 500 to 600 miles above the ground, not 22,000 miles. And they're rotating around the Earth much more rapidly, and they'll get stripes of information, as you see here in the image. So you'll have much less frequent images. Passes over the same point only twice every 24 hours. So you're not getting constant updates, but you're getting much higher resolution images because you're closer to the Earth. But it's very helpful as well because you're getting those high resolution images, and you can analyze things on a little different level in terms of weather. So those are definitely helpful for the weather analysis. Now here's a visible satellite image that you might see from one of the satellites, a geostationary satellite. And the white areas are the clouds, and the darker areas are usually ground, or the ocean will be even darker. And these are obviously only available when the sun is reflecting off the top of the cloud, so during the day. And as sun sets, you'll have darkness set in, and what we call the terminator will be moving across the country, and it'll be completely dark once the sun has set. Once the sun sets, we'll have to transition to the infrared satellite image, which is basically looking at temperatures. So the colder the clouds, usually the higher they are in the atmosphere, the whiter the image will be. So the warm ground will start showing up as dark, and then the clouds will show up as lighter. And then we'll put temperature scales to these to see exactly how high in the atmosphere the clouds go. But in this particular case, it's just white to black as a transition, and we monitor, how strong storms are based on how high in the atmosphere they are. Water vapor, it's not visible to the naked eye, but satellites can see the water vapor in the atmosphere before it even forms clouds. And we'll monitor moisture flows across the country that way. The whiter the image, the more water vapor is present, and usually at some point there'll be clouds, and then it'll be tracking clouds as well. So you'll see the clouds as the brightest white, and then less white will be the areas where there's just moisture progressing around that hasn't technically formed clouds yet. But we monitor moisture flows to see where storms are going to intensify or weaken possibly.